we've seen this in like SQL generation, and maybe this is a tactic we can talk about today, but like we've seen it like SQL generation. Okay, have the model generate a JSON object that can be turned into a SQL query. For
Yep.
SVGs, the TL draw guy was talking about this at AI Engineer last week. Have the model generate a structured object that it's good at writing that then deterministic code can turn into an SVG. And I think have the model generate code that then you can like bake. It's like creating different views of the same thing. And
Yep.
then once that's baked, then you can deterministically execute that code with the programming runtime.
Yeah. All right. Well, with that, let's get started. My name is Vaibhav. This is Dexter. We've been doing this every week for the last few weeks now.
It's been
And
months. We started in March, dude.
oh wow, yes, but we took a break, so I don't know if that counts. The break is where I define the line.
Okay.
But regardless, the whole point of these episodes with AI that works is to talk about real practical AI applications where we don't just talk about high level stuff, but really try and show the code behind how things work. We've talked about a bunch of things in the past, from MCP servers with 10,000 plus tools to 12-factor agents by Dexter, all the way to Human Learn, how to use humans as tools, and then just really how to think about prompts. But today, I think we want to do something that was different. It's going to be a lot more varied in conversation than our previous conversations, which were all about focusing on one depth thing. Today, we want to talk about just prompting as a whole. Nothing fancy, just plain old prompting. And many of you, uh, and actually, Dexter, do you want to give a little precursor while I get the screen recording up?
Well, I think like many of the things that we end up talking about, you can take like what is a really simple problem that folks kind of can look at and just say, "Oh, that's solved." Like classification. It's like, okay, I know how to pass the LLM a list of labels and get it to output one of those labels with structured outputs or something like that. And then you go and you look under the hood and it's like, "Oh, like actually there's a lot of room where I thought the ceiling was of like, okay, here's the techniques, here's how you do it. There's so much more room to basically open up the box and rip out all the wires and redo everything and like engineer it to get much better results. And I think like the core of that is always prompting. And so I'm really excited today to learn about both like just some basic techniques framed in terms of certain types of problems. And I think today one of the things that it will be cool is we're not going to talk as much about like one big overarching problem like we usually do. We're just going to give you a grab bag of small tips and tricks that are reusable across problem spaces and like lower level advice that you can apply to lots of problems. And I think hopefully, if folks are down, I think we put a thread in the Boundary Discord. If anyone wants to share their prompts, the most I've ever learned about prompt engineering is showing Fibob AI applications that I've written and having him roast my prompt and tell me what we're doing wrong.
Um, Actually, with that, what I'll do is in the thing in here, I will actually just post a link to this thread, copy thread, and I'll post this in the chat. If anyone wants, they're welcome to post their prompts that they want to share. This will be recorded. And like just post it on here. We'll fix your prompts at the end and we'll just show you how we would think about them. Doesn't mean that they'll necessarily get better. It might just give you another technique or two. But with that, let's go into the topic. Cracking the prompting interview. I think prompting is literally like software engineering, and we're just going to use the same techniques to do a couple of things off the bat. So let's start off with a very common problem that I always see, which is always the first one that I'm going to talk about, which is like labels. And this, I think the most common example of this problem that I see is citations. So imagine that I have a prompt. My prompt will have a bunch of text that I refer to it in for the context of RAG. With the RAG, I will have it give me like the URL or something attached to it. And I will have a bunch of these along the way. So I have like a URL with some data, and then I want to go get that. And somehow in my answer, I want the LLM to give me out the URL. This is this a problem that I resonates with this couple of people? Does anyone have ideas for how we could make this better? If not, we'll just go right into it. If today's session is going to be
Are
pretty
you
informal,
gonna replace the URL with a Sentinel token?
kind of, yeah, exactly. Because what I want is I want the answer that over here to be an answer, but I want to include the citations that remap to that specific thing. Now the problem is, as we all know, URLs can be really, really funky. Like just the URL for this Excalibur draw is, I don't know, let me see if I can share one. Like if I go to like, I don't know, the random browser page, I probably have something open. Where'd it go? Sorry. If I just go to like, for example, our YouTube channel, and we just show some of these videos,
Cool.
These URLs are basically I could have this as the citation URL for my model. And let's just take a look at what it would mean for the model to generate this. Let's just go look at the tokenizer, because I think this is the most important thing to think about if a model can generate something accurately or not. This is what the model has to generate. There's a bunch of tokens. So these tokens make sense. It can probably do this. YouTube is a single token. A dot YouTube is a single token. That's kind of interesting, actually. I learned that today. Watch is a single token. We're good. Question mark V is a single token, which also probably makes sense because YouTube probably is a predominant force in the tokenizer for some reason. But everything else here breaks down. This ends up.
And there's like models can generate a string. If you type in that string, you say, "Hey, model, make this string for me." It's going to make it. But your point is basically that like the
In
more
order,
tokens that you're asking the model to generate accurately, the more kind of effort it has to put on that, and the less likely it's going to get it right.
exactly. So in order for the model to get this part of the URL correct, specifically, it has to generate 10 tokens perfectly. If we remove this part, let's assume it'll get question mark V correct. It has to get 8 tokens perfectly correct. If it messes up in any of these, it becomes a useless link. So how can we change that? Well, we can do something really, really simple. And I will just use YouTube along the way. And I'll write a basic prompt that does this and tries to go about this. Oops. So we're gonna write a question, new file, like labels.baml. I'm gonna have a function that's gonna say given answer question. I'm gonna say here's a question. I'm gonna give it a list of links or content. I'll say like this will have like a URL, which will be a string, and then content, which will be a string, and then what we'll return here is some answer. And then citations, string array, at definition, list of URLs that are relevant. Okay. OpenAI, GPT-4o, great. And CTX dot output format. Sorry, I'm gonna live prompt, so I'm gonna try and be as fast as possible. Full user question.
Okay, so output format is you're telling it how to output the answer,
Exactly.
and
And then
you're putting the output format and the relevant content into the system prompt, and then we're putting the question in the user prompt.
exactly. So I'm gonna do this. So now this is my prompt. And I will literally just ask Cursor to generate me a test case for this RAG use case. Use resume.
They are all the same file. They're all going to
Yeah.
have a test case in them.
I'm gonna move this. Use resume.baml as a reference for how BAML works. So I'll just have it generate a test case really fast, and then it'll just go do something for me. But we can see how like, and then this takes a little bit, but we can see how like the model might struggle to go do something great, except cool. Let's go do this. And
Oh
then if I
man, are you going to make these URLs really freaking crazy and then see if we can
yeah,
actually get the model to screw it up?
I'm just gonna use this. So this is one YouTube URL, and I will copy another YouTube URL from a different video. And I will point this out. It's not even a matter of like the model will screw this up. The point here is it doesn't matter if the model does this perfectly or not. The point that matters is the model might screw it up. And if it screws it up, I have no guarantee on this end. So there's small things that I can do. So now that I have some citation thing in here, I can do something nice in my Python code to help reduce some of these errors.
Oh, you can put like a guard. This is from the eval thing. You can put a runtime guard of like, hey, if it outputs a URL that wasn't in our input set, bounce it back and
Exactly.
tell it to try again.
Let me actually open just this one folder really fast. That way it's gonna be a little bit cleaner. There you go. Otherwise, Python versions don't work for monorepos, which is the worst sin that Python has committed.
We're getting there. I think the uv.python stuff might actually eventually fix it.
I really hope so. So one thing I can do is I can literally just get the answer equals this, and then I can say like for URL in answer.citations, I somehow assert that the URL starts with this. I could like build some small asserts. I could assert that the URLs are actually in the actual content array that comes in there. Oh,
I got it. I'll get the link.
so we can actually go build this URL right for us. Now we can actually go further. The problem is right over here, these URLs, as we saw, have a problem with how the model is going to actually generate them. So let's go fix that actually. And let's say this is our actual URLs. From BAML client dot types import content. Cool. Now, what I can do here is instead of actually putting this URL as is, I could literally I could first change this completely and say what I actually want to do is I won't list the return of citations. I will actually list an index of the content. And now that this returns an index of the content, what I will do here is literally just print this out, content, loop.index0, content, IDX. And now my prompt looks like this. Instead of actually dumping the actual URL, I just say content IDX00. I can actually put like dashes here as separators. I can put them beforehand because that might actually be better. Content. I can do this. And now it's actually called content content1, content0. And now I just remove the idea of the URL completely from the model. And the model will not do this. And when I go run this, what we'll find is great, we get 0 and 1 because those are relevant indexes. And like let's make up a third one that doesn't matter. Europe is pretty cool and has great pasta. And ideally, it shouldn't pick up the right content. It should only pick up 0 and 1. And now what I can do in my code, instead of doing it in the model, is I can convert the URL into the actual citation. So now I can just say like content of URL dot, what is it? Content of URL dot URL or the actual URL that I actually want. So it becomes an index-based lookup instead of a real one. So the idea is you really want to do your best to not rely on models generating long sequences of tokens that don't make sense for the model to actually intuitively think about. This
Right,
applies.
There's no meaning baked into that random string of characters. It's just a pointer.
Exactly. And if you can go further, and if you go back to our content about dynamic enums, you could, for example, make this a dynamic enum that then has an alias that gets mapped back to the actual value.
Yeah,
And
I was going to say we could go into all of the fancy BAML features that make this
Yeah.
even easier. I am going to say we are 20 minutes in, so if you want to move on to the next tip, or do you want to wrap this one up, or do you have more on
that's
the
it.
label stuff?
The
Perfect.
Labels, it's don't use sequences of tokens that don't make sense for the model. Go update it on your own.
We got one question. Symbol tuning also applies here.
Exactly. Symbol tuning is the exact same thing. Docs will cover that. Can't talk about that right now because of time constraints. We're going to do another one, diarization. So we've all seen diarization examples. We're like, do this. Make a transcript to diarization function. Use labels.yaml as an example.
Do you want to do a quick whiteboard on like what do we mean by diarization? while it's
While
working.
this is fine, I will go do this. I'll
Yeah.
describe words over here. So let's talk about diarization. Diarization. Diarization is this idea that we have audio coming in and we want to turn the audio snippets into like a speaker plus transcript section. So each of these will always have a speaker, and each of these will, and then transform into like who said what. So the idea is most of these sequences come from, and what most of these will do is they'll basically say, literally say speaker 0, speaker 1, speaker 0, speaker 1. And you might actually want to go do something more than that because you might be having a conversation between a nurse and a patient. So you might actually want to say speaker 1 is a nurse, speaker 2 is a patient, and transform your transcript to that. I'm going to show you a prompting trip that is going to reduce the amount of text that we might have to generate by an order of magnitude to solve this problem. Because if I want to go from person 1 to speaker like nurse versus patient versus like other, because maybe their husband or wife spoke up into it in the middle of it. I want to know exactly who these personas are. So let's go do that.
Is real quick, I imagine this is probably equivalent whether you're doing audio or raw, just like a raw transcript of a conversation, right?
Yeah, so I'm gonna assume that the
Okay.
transcript is gonna have a speaker. Let's just say the transcript is on. Let's simplify this a little bit. Let's say the transcript is literally just a string. And what I want to do is I want to identify the speakers that exist for each of these, right? So the transcript is literally just going to be a string, and I have no other information about it. Transcript will turn into that, and then what I want is I want to return a diarized transcript, which is going to be a bunch of speaker segments. Don't need this, and this will just have speaker string text. And you might even say that this is like nurse, doctor, patient, or other. So let's like write it like here.
Cool.
Identify the speakers. CTX dot output format, and then role user. Okay, cool. That's probably good enough. Oh, that's actually pretty cool. Let's change
But
this
you
to
actually just want the raw text, right?
yeah. So I will. Oh yeah, that's true. Thank you for identifying that, Dexter. Actually, I think our test cases converted correctly. Uh, 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 are you? I'm hurt. My knee hurts. I'm sorry.
Sorry, so this is already has the speakers identified though, right? Like,
Yeah, but it doesn't tell me who's who.
okay. Is so would this technique work? Like, is this applicable also to just a like like if I just have a stream of text and it's not already split up by speaker? I guess
uh,
okay, so this just assumes you have turn detection, but not necessarily
exactly. Let's say we don't know who
okay.
the speaker is. We don't know anything about this. What we really want to do is we want to go and convert this in a really quick way. So I'm gonna go change it. It's been hurting for 3 days now. Fix. He's been complaining about it for a while. So this is interesting because there might be a lot of other content here. So let's just see firstly what the raw thing ends up being.
Yeah.
And cool. This seems kind of interesting. It's like cool. It has all these other things in here. Let's try and make this better really fast. And I'm going to combine like 2 or 3 different of the prompting tips right in one as I go. So the first thing
Cool.
I'm going to notice is, hey, this is probably not very useful. So let's try and just like
What
fix this.
what part of it is not useful?
Well, one, I'm outputting the whole transcript over and over again. That sounds
I
bad.
see.
Let's see if we can do this in a slightly better way. So what I'm going to do is I'm going to say dialogue index int. So I'm going to give it the dialogue index. And here I'm just going to like write this in my prompt really fast, so I don't have to think about this. But the right way to do this is honestly to just make this thing an array. Sorry. I love cursor. And we'll make this an array. And now, instead of dumping the transcript out as we are, what we'll do is we'll say for line in transcript, print out the line. And now what we'll also say is this, loop.index0, dialog this, we'll add an extra space in there, and then we'll add that in. So now
But
what
this
we'll
is
do,
an assumption that the script is already an array, or are we just converting the script into an array?
well, you
like,
can just split by, I'm assuming if you have some way of a speaker colon here, you have a way to convert this into an array of some kind.
oh, okay.
Right?
Yeah.
So
I think the questions that a lot of people are asking is kind of the real-time actual speech to text use case is you don't have those like separators unless you're using like a separate like turn detection model, basically.
yes, but most people should be using a turn detection model. So I'm assuming that you have that right now. You're analyzing a transcript in post. We can remove the speaker labels as well, so it's like a little bit more clear. It's like we just have all the statements that are literally speech to text per line of some kind. I'm gonna go run this now. Now you'll notice the model's actually really, really good at just spitting out the dialogue index and who the speaker is in each of these scenarios.
Oh, so it doesn't have to re-output the actual text itself.
Exactly. Order of magnitude. You can imagine for long transcripts, this is an order of magnitude cheaper in terms of how much text it has to output. And we can reduce this even further and just like alias this to like alias IDX. And then it'll be a lot shorter. And now it's just outputting the index and the speaker.
I'm
And
a little curious what would happen if you just put it all as one big string.
what do you mean? Oh,
Like if you didn't split them out. I imagine it's probably not going to work as well, but
the reason that this works a lot better is twofold. One, I'm actually telling it the model what the index is. So the model has to go back and say, let's look at what the model does turn by turn. It's going to first output IDX 0. Then all it has to do is in its token during the attention mechanism, the model goes back into its tokenizer. So it literally will go back through all the tokens and just say, okay, what tokens do I want to look at? I want to look at index 0. It's going to go into say, okay, I need to understand this part of the segment. It's easier for it to focus. So even though it's a little redundant, it helps the model be a little bit more focused on its part. Now it's like, okay, who likely said this? And then it's like, and then it goes out and starts spitting out the next token, spits out IDX. So at the point of IDX, now it says, oh, what's the next IDX I need? Oh, let me go back a couple tokens here. It's like, that was 0. I probably need 1 next. We're reducing the burden on the model. That's the main leverage here. The model at any point is able to do way less work and then therefore output more. Does that make sense, Dexter?
Yeah, I got you. Cool.
Cool. Now, the thing is, we may not actually know exactly who's talking here. Like this other thing, we might have made a bug and not actually introduced other. And in this scenario, what we'll find is likely the model will do something, just output it to nurse. It kind of hallucinated on its own. So we can actually just add other as a fallback. So the model doesn't tend to hallucinate. We want to prevent hallucinations when possible. And we do that by giving the model an out. That's another.
And this is the same with all the classifier examples that we talk about, right? Is like classify the things you know you are good at classifying in the fastest, cheapest, most efficient way, and then allow the model to have an escape hatch, in which case you'll handle it in a different way, either by sending it to a human to classify or sending it to a bigger, smarter model or whatever it is.
Exactly. But now let's do another thing. Clues. Let's add some clues here. So I'm going to help the model things that exactly. So I'm going to help the model think about what it is. And it's literally just dumping the text here. And like this is not very useful. I have description. things that help inference to, let's just add a little bit more dialogue here and we'll see what it does. Let's say what might relevant. So we're noticing that what it's doing is just outputting all the clues. But a lot of the times it's kind of obvious who the speaker is. So let's just do this. Only if not obvious. List out facts that help us identify, help us analyze.
Yeah, John's suggesting deductive reasoning steps, which I think is gets a little towards some of the stuff we did in the past around like structured reasoning stuff.
Speaker. Who the speaker may be. I had a much better test case pulled up earlier. So, and now you're noticing over here. Now
Hmm.
it's something a lot more interesting. It says speaker 0 other, because they don't know yet. Speaker 1 uses personal pronouns indicating injury. That means that they're probably a patient. Speaking about the patient, so probably other. Along the way. So it's actually a lot more useful to actually go do this. And now we can have a lot more confidence behind what's happening.
But it's also it's gotten worse at picking the ones where it was the doctor, right?
The doctor and nurse are worse.
Yes, but that might be because when you really think about it, the doctor and nurse are actually confusing, because how does it actually identify correctly between the doctor and the nurse? And we can go about this one more time. And if we actually go look at this, if I were to read this transcript, there is no freaking way I, as the human, would actually be able to know if it's actually a doctor or doctor or not, without knowing how many people are in the room.
Very true.
I could be
Right?
talking to my brother.
Exactly. Exactly. And that's the
This
point
could be
here.
my uncle talking
So-
shit.
So when you said doctor and patient got nurse, you're right. We intuitively felt that way. But remember, the model has no context around this. So let's add some more context here.
Could you go to, so before you clear this out, could you go to the third index number 2? Yeah, this time it seems to have gotten it.
Because it's making assumptions
Yeah.
about it, right? But
Yeah,
now
it's taking more from the prompt itself, like the actual output format, right?
Exactly. It's literally just like, you're probably either a doctor or patient. Like there's no way around this. But now that we force the model to be like, if not obvious, go list out facts. And in fact, the obvious answer for identifying speakers may be other in all scenarios. And that's what I would do if I would unlabel everything. But then I would say, oh, but now we know for sure that this one is a patient because it has been non-obviously stated. But we can go further. We can make this a little bit better. There were 4 people in the room. Dr. Josh. Nurse. 5 off. Patient. Next. Friend. Unidentified. So we can go do this, because maybe for my EMR, I know exactly who visited, but I don't have any information on the other person at all. So now let's add this in here and say for context. And now let's run this. And now what we find is that the model gets a lot better.
Right. So you could look at, like, if you want to do this for a random event, you could go get the people off the Google Calendar event and just inject that at the top. Be like, here's the people and here's their domains and here's, 2 sentences of deep research about who this person is.
Exactly. And this mechanism of how we felt like it got more inaccurate and might have diverted us from actually exploring this prompt further is actually important to understand why the model did this. Step back, rethink, and remember that the model did this because if I were to be completely objective, show this to a random person and tell them to identify speakers, they also would likely pick other. If they have to be like, if the choice would be wrong or be correct, I too would prefer to be not wrong and just pick other,
Yeah.
because other is never wrong.
Cool. Are we
tip
gonna do
number
triple backticks today?
I'll do that in a second. That's tip number 2, where we'd use diarization. And I want to show one last variant of this trick, which is these clues. So instead of outputting clues, we can just do this. Description as a precursor to the comment. As a precursor comment to this field. So sometimes we
Oh,
want it to
shit.
do, but we don't want it to do reasoning as a data field. I don't want to deal with that. I just want it to like output something. And I want to show you what happens here. If this works. Example.
Okay, so this is getting into like how do we this is a great leeway. This is like how do we get the model to output busted JSON in a way that like actually helps it get better answers. Like comments in JSON are technically not valid.
Let's see if I can force it to do this. I have to actually read the prompt and see what it's doing. Use as if speaker is ambiguous. List relevant comments to help narrow down toggle to help narrow down the speaker. Use first. Cool. We'll go run this and see what the model does. Okay, I can't get to do it. Let me try and put this out. This is like the weirdest trick that I've learned, and
So not directly in the generated output format, but just in the prompt.
and use first and had an accident.
Okay. So you always tell me not to use few shot prompting.
I do.
Because this is more about the structure of the response, not about the actual like learning from examples, basically.
Exactly. So let's see if I can get the model to output this. And sometimes I can't. Sometimes the model doesn't really listen. And just dump that info as another field. So let's do another last thing. Prefix equals answer with this. I noticed OpenAI has been doing this. Where like, I think for whatever reason, whenever you use the word JSON, they trigger something special in the prompt that goes to like some other model or something.
Or like secretly turns on. Oh, there you go.
Yes, exactly. And now the model's actually writing some more comments, but it's writing the comments after. If list relevant facts help narrow down speaker before the speaker field. So it's be a
Want
little
the
bit more.
reasoning before the output.
Yeah.
Question. So the reason to do this is to save the tokens on writing clue every single time, or it is?
It's not always about that. It's just like the model might just, it's just another tool in your toolbox for how you can get the model to output what you want. Clues is one way to do it. But
And you could also do the thing we do. It's like put the reasoning at the top and then dump the JSON. And it sounds like this is just like, okay, if we want really targeted reasoning on each field,
Exactly.
and maybe like this is way more token efficient than having it output a bunch of extra JSON.
Exactly. And
Got
you'll
it.
notice that you saw me iterate a little bit on this prompt over here. Like I did a couple of things to go do this, but this goes into the very next tip that I want to really talk about, which is one, it's called RTFP. For those of you that don't know RTFM, it means read the fucking manual. RTFP means read the fucking prompt. And I say that with a lot of love because most people don't actually read the prompt. And you saw what I did when this didn't work over here. I just read the prompt. I was like, oh, if I go back to the at description mechanism, let me give you a little bit more of a description of why I didn't like this. When I go read this, I'm like, oh, this thing over here, maybe it's getting confused by the double comments. And you can see how that might be confusing to the model. So since I'm using comments, like nested comments in comments, I'm like, okay, let me just try and simplify this problem for the model and give it that in a place where it can't be confused. And that was the intuition that I had out here. So it really just boils down to reading the prompt, because if we can read the prompt, then we can see what the model might be doing. And of course, we can never actually know what's actually happening, but it allows us to actually know it allows us to iterate a little bit faster, and then we can say, oh, that isn't working, let me go fix that. There's a question about why not use few shot prompting. There's a couple reasons. Typically, the way to have done few shot prompting in this example would have been me to actually go and write an example and then write out the answer, but that's not what I wanted. I just wanted the model to understand that it has the ability to go do this. It has the ability to list out facts before it actually spits out the speaker field. So I just wanted to give it the structure so it understands the thing it has to mimic.
Yeah,
It's not the
you can.
content. Go ahead, Dexter.
Yes. And all of this is again is like, okay, cool. Like, yeah, probably just outputting JSON is good enough. Outputting reasoning first is a little bit better. Having reasoning in your JSON fields is probably a little bit better. But if you're running this kind of thing 100,000 times a day, then a tiny 0.5% improvement, either in efficiency or in speed or in token efficiency or in accuracy, is massively valuable. And this is what we talk about every week on this show is like how do you unlock those like near the top of the accuracy range? How do you push things even further?
Yeah. How do you get another 0.5%? And
Yep.
this isn't again, remember, this isn't say that this technique will work always, but it is another technique that you have available to yourself. Just like we use this other technique to not spit out the entire dialogue, but rather only spit out the index. And we use this other technique to say, oh, dialogue index is actually a lot more tokens. Let's use purely the word index instead. So it spits out the output tokens are way less. It's small things that can make a difference. And if I actually were to look at this, my hunch actually says index itself, where'd it go? Index is probably wrong. I should actually probably use like index, because this is just a more popular token that the model will have understandings of, or rather than IDX. Even though IDX is a single token, it's just more commonly understood. Cool.
So
I thi-
quick question. So we do this actually hundreds and thousands of times a day where we put out reasoning, and we use the reasoning as eval for another model. So is there a way to achieve or make it a bit more efficient? So we literally spit out clues, and these are at least a long sentence. So any tips or tricks to make it
Well,
more
one
efficient?
way is like if you really wanted that, I would actually put your reasoning afterwards, like assessment. So if you want to do an eval thing right over here, description, final assessment of the speaker, given any prior clues in comments. I would just do this. And just like let the model spit it out, and now you can use assessment as a thing. But now you'll see that assessment is actually kind of big. So what I'll do is like use phrases. not complete sentences. And then I would also add into here assessment. So now I'll notice over here what it's doing, and it will just spit something out. And I would probably have to tweak this model. So sometimes GPT-4o is not very good. So let me try Anthropic. Is that the right model? We'll find out. Oh, that is not the right model.
Dude, I think it's 1020. 2024 1020.
Custom Sonic.
There you go.
Oh, I don't have an API key. 1 second. I will not be sharing my API key this time around.
Oh, that's why I come here every week. It's because you always leak at least one key.
I also forget to deactivate it. Okay. Let me.
Yeah, and just answering while he's doing that, answering the question in the thread. Why not use few shot prompting? We talked about this a little bit, but it's basically the content of the examples tends to greatly steer the model's response. And
so check
how do I
this
say
out.
this? Like you can get the right structural results without actually putting content in your examples.
Yes. So there we go. So now you can see over here, when I switch this Claude, I actually get really nice things where its assessment comes with this. And now you could plug this into your evals. We got a way less tokens out here. It's way shorter. Because we're not using complete sentences. So if you really care about evals and want to if you want to store the data anyway, go do that. But honestly, if it were up to me, I wouldn't do any of this eval stuff online. I would have a separate process that pulls all my data down and runs a separate eval, including the assessment for each of these segments off the raw data itself. And just run a completely separate process. It's going to be way cheaper, way faster, because don't add more latency to a pipeline that has this. Each of these things that you're generating here is latency. So a very latency sensitive pipeline, generally for speech to text.
Cool.
Cool. Let's talk about, so at this point we've covered labels. Don't use UIDs, don't use URLs, use like indexes whenever possible and remap them programmatically to the right thing. We've talked about diarization. Don't emit the full transcript. Have the index, have the model represent something that is way better than the full transcript. In this case, an index of transcript. We've talked about using inline comments to guide reasoning of sorts. We've talked about RTFP, reading the prompt. Read it always, especially when you get stuck. Instead of trying to keep prompting more, just keep reading it. We've talked about few shot prompting with structure, not with actual content, and how we can leverage that along the way. And I think the next thing I want to talk about is something that we've mentioned a few times. It's all about code gen. So I'm going to go ahead and pull up a random new file.
Hey, Vaibhav, Anubhav here. Before you move forward, in my mind, I'm still confused about using this technique where you somehow use Jinja to get an index on that array.
Yes, good.
Versus using symbol tuning thing. So when to use what?
Okay, so just for context, let me just pull up a symbol tuning example, so then we can just talk about it.
What do you think, Kate? I know it's different for financial services, so it's like the one.
I have symbol tuning right here. So the idea of symbol tuning is I want to do a classification example. I guess I'll do this. Symbol tuning. Oops. Okay. I have a classification prompt. Instead of actually classifying the prompt, I want the model to spit out one of these categories. And I have a couple different ways I can go do this. Oh, that's interesting. I have a couple different ways that I can go do this, but one of the ways is like, instead of the model actually spitting out all of my classes, I can, and instead of actually writing like the word refund in the prompt, I can write just the symbol K1. And when the model runs this, it will spit out K4, which then gets remapped to account issue for me automatically. The benefit of this approach is the model, again, it's the exact same thing as a YouTube URL thing, where the model when it sees the word account issue, it associates these tokens with something semantically meaningful. And what I want to do is my meaning of an account issue is actually encoded into my description, way better than the actual
You want to
label.
say zero attention on the label name because that's for the coders and the program that's consuming this. All attention on the description so that I can control exactly what the LLM is going to output.
Exactly. Exactly. It's about reducing the number of variability in your prompt. Dexter said it beautifully. And symbol tuning is a technique that lets me do this. The thing that we're talking about with diarization, where we actually output like the actual index here, that's basically the same thing. Instead of the model outputting the actual text of the line, it's outputting the index of the line in the conversation. And instead of letting the model infer the index, because I could do that. I don't actually have to write this. I could just let the model infer the index by writing something like this instead.
Just
And
like
the
put a
model-
break. Yeah.
Model could count, but why make the life harder for the model? Like this
Yeah,
is
now you're
way-
asking the model to count shit. Are you kidding me? That's terrifying. It's like you know, when you do these coding agents and you have like no line numbers in the file versus every time you give it to the model, you give it line numbers, and suddenly it can do these edits way better, right?
Exactly. And this goes back to RTFP. If I read this prompt, even as a human, I know exactly what index this is without having to spend any time about it. But if I don't have these lines in there, that becomes a lot harder for me to go do. And I think it's small things like this that actually dramatically change the quality of your outputs in a way that I think can make a huge difference. So Anubhav, I hope I related the questions across the board for the one of how symbol tuning relates to diarization and the examples
We won't go into this today, I think, but like again, take all the advice from the evals chapter and like don't go just applying all this stuff willy-nilly. Like get a real set, understand how your performance is today. Try changing these small things, you know, whether it's like, oh, I found a bug from production, let me drop it in as a test case and just change the prompt until I fix this one without breaking all the other ones. Or even having a bigger eval set, which is like, hey, our accuracy is 84%. And if I make this change and run the exact same data through the pipeline, now it's 88%.
Exactly. Let's
Cool.
Let's start with the last part, CodeGen. This is something we showed a couple times, and this is kind of related.
Well, this directly leads from the other one because it's like, how do we get the model to create invalid JSON for good? Like how can by getting the model to create broken JSON, you can actually get way better performance, and we'll talk about like why that works by looking like under the hood at like samplers and stuff, right?
Yeah, let's do that. That's actually a good idea. So in this case, I wanted to generate some code, and I'll say a binary search tree with actually no, let's do this, a sorting algorithm with merge sort. Okay, cool. That's redundant. So let's do this firstly. And it's going to output this. And again, if I have a chat app, this is excellent. This is really, really excellent. I could show this to the user. They'll be pretty happy, and we'll see the quality of the code right here. It looks pretty good. It has some comments and stuff in it. It looks generally useful. But the minute that
this is the way models want to write code, by the way. Like this is if you just want to get the very best code performance, let it write it between markdown backticks because that is what is the majority present in the training set.
Yeah. Now I'm going to change this to actually return a data model because, hey, I want the code so I can go find it. I don't want to do some parsing. I want to render it just the code part without all this prefix, or maybe I want to go run it and go do something.
Right. You don't want to have to write code to strip out that like Python backticks thing because you're just going to turn around and run it maybe.
And now we got this. And I don't actually know the quality of this code, but we'll see. All I do know is it did output a lot of things. And I want everyone to note something very, very important here. This is actually what the model output. This is raw. I just copied directly the string that the model came out with. If I go back to the tokenizer, I'll show you. I want to show everyone what this means. We can see what it did.
Yo, slash and n are two different tokens?
Yeah, exactly. So it's actually
that's crazy.
/n. It's outputting a bunch of space characters. It's not actually outputting code. It's outputting something slightly different. It's something that looks like code.
Sorry, can I screenshot that and then can you drop the other output into the tokenizer as well? Sorry,
Yeah, why
Eric,
not
pop
put
back and let
side-
me get a screenshot real quick.
Yeah, I'll put it side by side. How about that?
Okay. Yeah. Because I think this is really important.
Okay.
So
Right.
if you get rid of the backticks and the actual like preamble and stuff, how do the tokens
No,
compare?
I'll leave that in there actually.
Okay.
Because I think it's important. And this one has like a Java example as well. So why not get rid of the Java example?
Yeah.
Just to like keep it in. There's something in here. Cool. And this seems to have a print example as well, so we'll leave that in there. What we'll notice here is it's not really about the token counts or anything else. What's really important here is like the quality of the code that's being generated. First thing that we notice up front is recursively sort both halves. So this comes out, and then if we go look at this, all these \ends are actually having to be forcefully generated by the model to be correctly syntactical JSON out of here.
Because you can't have new lines in JSON. You have to have escaped new lines.
Exactly. Instead of letting the model just do escape new lines. So what if we just told the model to go do that instead? What we'll find is code description, use backtick, use triple backticks, the format code, Python. And let's go read the prompt. Let's see what the prompt looks like. This is what the prompt looks like. Use triple backticks to read the prompt. And now when I go run this, what I get is the model will output code exactly how it was outputting before, but in a way that still allows me to do structured prompting.
So this is not valid JSON. And like the subtle thing here is like, and this is kind of like, I think we were having a conversation yesterday about like one of the cool things you can do with BAML and why having a parser that is separate from the that is outside of the model itself is really powerful, is because you can let the model use regular new lines in its output and then turn them back into regular JSON that works.
Yes. So now let's go do this. Now I want to make this as a lesson plan for the following input as a lesson with diffs. So now what I'm going to do is I'm going to output an array of code snippets, not one, but multiple arrays. And then I'm going to say, make a plan to go do this. Example, section 1, blah, 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 section 2, blah, 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 blah. Cool. And again, we're using FewShop with the example of using comments as guiding principles. We're going to do the same thing here. And then we'll have a little title here, string.
This is funny. This is what I actually did for a workshop a couple weeks ago, was we had said, hey, here's the final product, output it as sections in a lesson plan.
So now we're going to do the same thing. And now what the model is, I'm fixing this bug.
I mean, this is cool, but why would you want to do it this way? Why would you want to do this, I guess?
I'll show you the output because I think the output will make it more clear. So the first thing is I wanted to build a lesson plan. So I did reasoning for like what lesson plan I wanted to go do. So it said, well, we're going to go do this. Then it's going to actually output the code and create a merge function that combines two sorted arrays. Great. Create a basic merge sort function with recursion. So it's actually incrementing it. Now you can imagine that I walk someone through the code one by one. Right? And now it's doing the same thing. Create a sort with array splitting recursive calls. So now it's incrementally going to do this. Now I can build a UI on top of this that literally has step 1, step 2, step 3, and teach someone merge sort with this benefit along the way. Right? And along the whole time, if I get rid of this section, I will literally just comment this part out. And I'll show you how much harder it becomes for the model to actually generate this. Like this is now like becoming significantly harder for the model to actually keep track of its own code. Because even as a developer, this would be very, very hard for me to even read and understand this. And most of the training data in the model's code gen doesn't actually have \ends as this. It has it as the actual \n. So the code quality that you're getting is going to be way worse. So when we go to like a harder problem, let's go into a harder problem because merge sort is something that we all know, like even the basic models can go do. Create a, what is it? What's a harder problem, Nexler?
Kubernetes operator to spin up RDS instances in Golang.
To spin up RDS.
Spin up, yeah, instances in Golang.
I have no idea. I have no idea what half those words mean because sadly I work in algorithms land. And we're seeing what the model did. So I want you to
Oh, it
notice
made a
something.
diff.
Yeah, so
Gross.
this model has made a diff. I also want us to notice a couple other things. The model actually intuitively just put out backtick new lines anyway. It actually was like, you know what? I am not going to put out \ends. I'm just going to spit out this. So the model intuitively did this for us without us even having to prompt it that. And that just goes to show that the model's intuitive behavior is not to spit out escaped JSON. And the reason it probably did this is because Go is just a lot more technical than Python or TypeScript and other things. So the minute it got to like a hard mode problem, it did the most basic things for itself.
Yeah.
Which was-
You want to pop back to the whiteboard for really quick and just highlight? I want to highlight the sampling part of this.
So you have it too.
Yeah.
There you go.
So okay, so you got that up. Scroll down a little bit. So basically, like if you know how samplers work, essentially you have at any given point you have the model's writing code and it's writing like code import OS, and then at any given point let's say we're right here and we're generating we're asking what's the next token. At this moment there is a distribution of what the next token's going to be, right? And in this case it's almost always going to be like new line, kind of classic new line, and then there's going to be a long tail of other characters that might be next, right? You might have semicolon here, because maybe some code has like import OS semicolon and then another import. Maybe if it's red code serialized in JSON, maybe there is a // here, which is going to lead it to correctly type the /n. And maybe there's some other characters here defined by your temperature, right? Of like different probabilities of that's the next token. Does it make sense?
Yep.
So when you put on strict mode or strict JSON mode, and even in some of the more like old school function calling modes, they're starting to enforce this. Basically, that is going to, when the model gets to its like time to do the correct output, it's just going to X out anything that would break the JSON schema, which means that a new line is not a valid character because a new line is not valid JSON. And this is why when people say like, using strict mode reduces the accuracy of your outputs, it's because now you're removing the big one and you have a very, very like tight distribution of the other things. Now these probabilities get balanced out and you have a bunch of things that are like probably next, but like not clear. And so you're likely to get weird janky code with like semicolons in it instead of \/ or even like invalid syntax because you're not letting the model write code in the way that it's been trained to write code.
Yeah, and this applies not just for code gen, but it applies to any domain where anytime you're having the model not pick its best token, you're basically telling the model that you know better than the model, which may be true in some scenarios. I want to articulate that. But most of the time in machine learning, what we've learned is let the model do what it does best and just let it output the best token. And in computer vision, we have this problem all the time where we always let the model, we try and be very clever about the model, where we do, let's do this pre-processing, let's do this post-processing. It turned out the best answer, as all the VLMs have showed, is literally just give it all to the model, let it decide. And I think the same thing is true with token generation or everything else too. Like, don't try and be clever with token generation, just let the model pick the best token. I think that's all we have time for today in terms of actual topics and prompting techniques. I hope that this was incredibly useful for everyone else. What we'll do for the next 15-20 minutes is I'll go to the Discord and I'll see what prompts that we have submitted, if we have any at all. And
There's a couple in here.
Oh, there are. Oh, that's actually more than I expected. Okay.
There's 2.
Exactly. That's more than I expected. But I will I'll do here is I'll go do this. Let's just bring this one up. I use this prompt to evaluate LLMs on their ability to make sense of LM generated events. But before we go into this, does anyone have questions while I go read this prompt that people want to go ask for? Feel free to come off mute and just ask if you after you raise your hand, and come on in.
So I
Oh,
do
hi.
have a question about that code gen stuff. Just because like when we're talking, yeah, I do agree that like letting the code gen do its thing is much better and produces a lot better results. But on the other hand, like when you're working in an established code base, usually it has its own like style and things like that. How do you resolve that problem?
Yeah, my Dex might have his own opinions. My answer for all of that is always the same thing, which is just add more software on top of it. If you want stuff to be formatted in a good way, literally just run a linter on the generated code. It will be formatted exactly how you want it to be formatted. If you don't have a linter with an opinionated formatting, it's probably not mimicking that. If you feel like you don't have the linter rules, go write a quick LM prompt to look at your existing code, generate linter rules off of that, and then go run the formatter. But find
Oh, because what I've seen in coding agents is a lot of like, okay, cool, read a couple, like if you're using Claude Code or something, it reads a couple files, and then what it's read in the code base already kind of propagates down to the next code it generates. But it almost sounds like what would be much more efficient would be like take a couple of the files and have the model generate either like hardcore linting, because not all style can be enforced by a linter, right? The linters are getting better, but not everything. But like either create a biome rule set or an ESLint rule set or whatever it is, or even just create a prompt that is like, here's a bunch of examples of how we write code. That so the model doesn't have to read entire files, but you capture it succinctly.
Yeah, and to do a little bit of extra legwork to find the models that represent it. And I think this is the same way. If you think about like just hiring a new developer, there's ways to build your dev team where you're like, people on my dev team will just figure out some coding format and alignment. But if you really care about code quality and want it to be consistent, then you add a linter, you add a formatter, and then it becomes uniform automatically. So like, and the most ultimate way to do this is to end up using some language like Go, which like forces like, if you want to export things, it has to be capital. Like developers don't even get a choice. Or use Black, which is like a very opinionated Python formatter, which says no configuration, it's just the way it is. And I think the same things apply for like stylistic guidelines.
Yeah,
Does that
that
answer?
makes sense. Yeah, I think there's also like in Cursor, for example, there are also cursor rules.
Yeah.
Which I think also help with this, although I haven't really explored a lot of it, cursor rules.
Yeah, cursor rules are a great way to go do that as well. But I think like if you're building an app that generates code, then you can't use cursor rules. So then you have to build your own equivalent of cursor rules.
Mhm.
That's really, if you're using cursor, then cursor rules should hopefully just fix that for you while cursor does this. Since cursor has built a system like this, they basically added a lot of software on top of their code gen to make their code gen more in line with your code base. Come on.
That makes sense. All right, thank you.
All right, thanks, Jonathan. One last question, and then I'm going to go into this prompt now that I've actually read it. Cool.
Going
If
once, going twice. All right, Hack Night at GitHub.
Okay. So this was a prompt where it seems to be like someone wants to look at an LM and come up with like some sort of like a plan for the most of this event.
I
So
mean,
I
it
think
looks like the prompt is basically come up with a plan, and the rest of it is just input context, right?
yeah, exactly. So the first thing that I'll notice is like, let's just go back and write this prompt. And actually, yeah, plan.baml. Function make event. Well, actually, I'm not gonna actually do this. I don't want to do this. Right. And this thing will make this a better function. Okay. So the first thing I'll notice about this is, oh, what the heck? Did I not pay? Oh, that's so funny. We have a bug. We have a That's so funny. We have a bug where in
Does it
Markdown,
come in as like markdown front matter or something?
it's like dash dash dashes comments. I think we strip it out. That's so
'Cause-
funny. Um,
Fascinating.
so like the first thing when it comes to this, so let's catch everyone else on what this prompt is. This prompt is pretty simple. It says come up with a plan to make the most of this event, and then you dump the actual event from like Luma or something else out there. Now, the most intuitive way is to just send that to the prompt, and like if we send it to ChatGPT, it will go do something. So like if I have this.
By the way, if whoever wrote that prompt is here, feel free to come off mute and give a little more context around what this is and what you use it for.
Yeah. So I'm the one who posted it. This is how Luma has like 100 events a month in San Francisco, and I don't read them all manually at first. So I use something like this to try to surface the ones I want to go to. And this is how I found out about BAML. So, a pretty
Right.
crude
There you
version
go.
worked for me. And I just want to make it a little more comprehensive, systemic, and all that. And, I just don't have an actual process for it, but I know it works for me to make the sense of San Francisco tech scene. And I think I could do more with it.
Yeah, so over here you can see what I come up with, and this is typically what you'd expect out of this sort of thing. That said, what I actually want is, and this is step number one, literally just stop asking the model to actually go do, like spit out the plan as a string, have the model actually spit out a preparation stuff for you of like what to go do. And when you actually go do this, let's actually paste, I'll just copy and paste this in myself. I think I copied and pasted this example as well, so I'll make this a test case.
I like the Discord only lets you copy one time.
I know, that's so funny. Cool. Great. So I have this test case now, and when I go run instead of the model actually spitting this stuff up here, it's actually giving me something a little bit better of like what I can go talk to. And in this case, I have a way better experience of like who I actually should go meet. And I can make this more targeted by simply just changing my schema. Class networking. Class networking opportunity. Okay, name, reason, string, value, value, high, medium, low. Description, how valuable.
Yeah, we'll push all this code, John.
The person is to myself and my career goals.
Yeah. The other thing I think would benefit a lot here is like a lot more context about me and who I am. Although I guess if you're probably pasting this into ChatGPT, then you have your memory and stuff at play to kind of like give that grounding.
So the main thing that you'll notice here is I'm actually going to change this. I'm going to make this a lot better. I'm going to say that this is, I want to meet these people, value, and then it's going to dump out the reason for why. And you notice that it actually changed out a lot of the more generally specific ones. Like this was very like random, but this is a lot more pointed and oriented, and I can go act on this. What else I can do here is I can say like, I can actually change this at like entity. Class, company, type, company, name, class, person, type, entity, equal this. And now when I go run this, it should actually spit out what I actually want. So now I can actually go like specifically look these up, and I can build a small little UI around this, like a React component that actually renders these in with like LinkedIn searches and follow-up sequences on top of that. So then I can just go ahead and say, oh, here's a link to the company's URL, here's who they are, and here's how they are. And this is just like AI/ML speakers. Cool. No one specific was highlighted on there, so I don't actually have like anyone ambiguous. People are ambiguous there.
But if you put first name, last name, you could also probably force it to like it wouldn't even output that, right? Like if you want to drive the output to the point where it's like, okay, I only want things that are actually useful. I don't want this kind of like hallucinating, sloppy, like talk to AI/ML speakers. Like, okay, that's bullshit. Like I only want like you to pull out people with actual names. So it's like if there was a speaker name in the description of like this person will be speaking, then it could go tell you some things about them.
And we can guarantee that at least the first name or the last name exists. And then all other entities will just get dropped. So we still get these, but then they actually just get dropped from our final parsing because like it doesn't meet the constraint that we need, which is first and last name need to actually exist. So even if the LLM generates it, you can drop it. But the whole point of this is instead of actually having the model spit out a string, what I really did is I focused on what I care about, what I want to see, and what I want to personally derive out of this prompt, which is I think what John you're trying to do is like see if things are going to help you like grow out of these events. So then I would just focus the specific stuff on here to say like focus on how it helps me and myself, it is to myself and my career goals.
Yeah, guide the reasoning with as much context as possible. And I bet if you took this JSON object and dropped it into V0, you could make a nice UI for this in 60 seconds.
Oh yeah, I bet. This is same in line with this. Make a UI for I'll probably go do something.
Yeah.
And I'll go build some UI for me. And now we have a full app that we can just go use directly without having to think about it. With small little rendering stuff as well. Come on, this takes a while. And then you
Cool.
can do whatever you want with your app.
We got time for
Yeah,
one more prompt.
another prompt in there.
Can
I
just
saw
drop it in
someone
the
else
chat,
typing in.
or
Sorry, go ahead.
can I just drop the prompt in the chat, or should I?
It'll probably be
Discord.
too long, but you will have to do it on the Discord, sadly.
Oh yeah. Okay, cool.
Prashant had another one as well that was answering questions with like verbosity and things like that.
Yeah, so actually you kind of answered many of these in the previous
Yeah, That's
examples.
what I figured.
Yeah.
Okay.
And then we'll do the last one really fast while we're out here, and while V0 is loading. I hate this. This is the part I hate the most about V0. It takes so long. Okay.
A lot of deterministic code.
You are tasked with a video editing plan. Okay.
This is sick.
Okay, I'm just gonna do this. Okay, so right over here, by the way, we can see this. So now it has a fun little UI for me to go build this in. Not to edit, just to view the final outcome.
Oh, do you find the frowny face makes Vercel make better content?
No, I was just annoyed that it did the wrong thing. Video gen.
Well, maybe if you went and read your prompt.
Well, I can't read the V0 prompt. So it's a little bit harder. Insert script expert here. What is this trying to do? Do you have your data models and everything else on here? If you don't, then I can try, but it's harder to do without like actual function types because this prompt is a little bit more complex. But let me just give you some general guidelines that I see right off the top of my head when I read this prompt. The first thing that I see is I don't actually think you need all this data. Like this is a lot more redundant. I'm not sure if this is all a system prompt or a user prompt, but when I go look at this, the first thing that I see is that this is not, it's like mixing and matching both the content and the instructions all over the place. Because like you're listing out you have instructions, content, instructions, content, instructions. It looks like more content.
Oh, this is the output schema.
Oh, this is the output format. Yeah. So it looks like you're.
But then there's more instructions.
Yeah, it just feels like we're mixing a lot of instructions, and it doesn't read in the way that I would write this if I were a human. And we're also writing a lot of things that's like you are a blah 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 blah. Like the model doesn't care who it is. It just has to know the job it wants to do. You don't need to tell it this is my role. If you notice in any of the prompts, I wasn't like you're a senior engineer that does blah 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 blah. I'm like write the code from this prompt. That's like the first thing I would do. So let's just like, there you go. And by the way, for people generating this, now you can generate this kind of UI automatically from here. And this would be super, super easy for me to go code gen. And then I could put buttons on here that I'll call like enrich, which calls another LM function that finds all the data about that company using like a research thing that I go build. Sorry, I context switch really fast. But let me go back really fast and start a new chat thing. Make this prompt better. No XML. And the error rendering markdown is the thing that hopefully we'll fix in.
Yeah, Prashant, the URA, we were just talking about this before the episode, that like asking models to adopt a role is I think the best prompt engineers out there have been talking for months about, if not longer, about how that doesn't really work very well, or like it doesn't have that much effect on the output.
The funny thing is that this comes right out of Claude prompt generation as well.
Yeah.
I bet. This
Just
is why I
because there's a
don't-
lot of data in the training set doesn't mean it's correct or good data.
Yeah, just like the most code out there is kind of shit. You probably shouldn't follow most code. But a lot of code is still very good and you should follow that, but it's all about finding the right segments. So in this case, the first thing I do is like, get rid of this. Create a segmentation plan for the following script, breaking the logical for each segment, ensure it contains complete thought or idea, estimate a reasonable time, consider the pacing. And it's important to kind of like describe what these mean, because it probably doesn't actually know. And I have no idea what it actually means for fast, slow, or medium. Like it just made stuff up. You need to go and actually understand your own thing for that. And like if you
Or you
actually,
could even force it in the schema, right? You could be like, okay, cool, I know how long this is, and I can say I want exactly, do it in code and say I want exactly 40 cuts because I want 30 to 40 cuts versus something else.
I want a
Because then we're not making the model count. There you go.
And instead of actually outputting all the stuff, I will actually just literally tell the model to go do this. I will literally tell it exactly what I want the pacing to be. Instead of describing all the pacings, I will specifically only emit the pacing that's actually relevant to the model.
And that's the same thing. The user and the program see a single word fast, but then you translate that into more verbose instructions, but only the LLM sees that part.
And the LLM is not seeing everything else. So if I change this from slow to fast, it sees this one. Whereas in this one, it sees slow. Right? So now it's able to actually go do this along the way. And now when I go
You can
do
run it.
Why not? Yeah, why not? And I don't even know what transition is. Like if transitions have a separate cut, like sure, let's do this. Let's just run it this way. And it's able to go do this. Now duration is kind of misleading, and the description is kind of seconds. I'm gonna change this. Ilias.
I don't think we need duration because the duration is essentially the content, so we can skip it.
Yes, but you might benefit from actually having duration in there just so that a model can like plan for each segment. It's the same
Yeah.
thing. It's
Expected duration, kind of, right?
because you have a thing in there where you're thinking about prompting, but you want the model to also be thinking about duration, like the amount of inference it has. It's about the amount of caches. Why do we have a Redis cache? Not because we can't go to the database, because we don't want to go to the database all the time. Why are we putting duration here? The model can just like kind of think about this. Now we see that this content is like pretty short form, which is totally fine. But if we want this to be the full content, then we can just do this. We can guide the model to generating more text.
Well, I think your input test case is really small. I think this is actually the right text straight from the input thing. So like we need like a way longer script to really test this anyways.
So I'm
Can I
gonna go do this.
can I drop in a script? I have one.
Yeah, drop in a script.
Yes, that's a script.
Yeah.
Fuck yeah. On the fucking AI that works.
There you go. History of
Nothing like that.
computing.
I like this. We should do this more. We should take people's real problems and solve them.
Let's run it. Right. So you can actually see what it did. It actually spit out all the content as a line.
but the duration seconds is 60 for everything now.
Do you still want it to be a list, Vibob, or do you want to just be a single string?
We can, oh, sorry, yes. Estimated seconds. Let's give it some description. Like how do you estimate duration?
Let's say every 1000 characters is a minute or 60 seconds or
Okay,
something like that.
Oh, are we gonna make the model count characters?
every, like, let's try this. 1000
Every
character.
typically every 120 words per minute. So you can count words or characters. I don't know.
Words per minute. What is average? Right, and we might actually find that, like, hey, if we do this, it's actually, when we do slower pacing, it's going to be a little bit, it's about 100 words per minute. If we do this, it's going to be like 120. When we do fast, it's going to be like 150. So you might actually like find that it's useful to actually guide the model appropriately for the different use cases, because that's what I would do. I would have a slightly faster voice in general, not just like the pacing.
It would be interesting to also have this like start suggesting like, hey, what do you want to show on the screen during this cut, right?
Exactly.
And
So
then you
now
could do
with
like a image search and pull that in.
background image. So let's do that.
This would be a fun building like an example of this end to end of like how to just like generate automated video content from little scripts, an end to end content pipeline.
To make
You can
it
come help me build my company.
I was
Yeah,
gonna say,
product.
yeah, we have to be careful not to build an open source competitor to Sahil.
I would love for that.
a description that is
So I
like-
have a couple of questions over here. So earlier in the example, you were showing how we can create indexes and to make sure that we are not spitting out so much text and saving tokens. I know, like, obviously this is a slightly different case where we have to spit out the text. Are there any tips or tricks we could use to do that index thing in here in any way, shape, or form?
Well, I don't actually know if you have to spit out the text in form. Like, honestly, you could just make this a lookup table based on strings. Like, you just spit out every line, every sentence into itself as like a thing, and then you could have the model spit out like a span. So like from dialogue 1 to dialogue 7, do this. Dialogue 1 to 3, and it'll naturally find breakpoints in the dialogue, and now you can go do that. You can build a separate pipeline that says, if you really care about like cost and latency, I would build a separate pipeline that says, given all these dialogues, what is the most intuitive breakpoints to inject into here? And then you go generate the background image and everything off of that. So you can solve this problem in many different ways, but it's more about identifying the indexes of where the breakpoint should be for where transition should happen.
Oh, so it becomes similar to kind of almost the diarization, where maybe you just wanted to output like the first, like the biggest, like the smallest unique chunk that like offsets the text there.
Exactly.
Cool.
Exactly. Where would you go inject that?
Cool.
With that-
We're 90 minutes. We should probably wrap it up. This was super fun, y'all. Thank you so much, Vibob, for sharing your prompting wisdom. For those of you who made it to the very end, congrats. Well, there's no prize except that you got to learn more. And we will push all the code and the video, and we'll send out a blast. And come catch us next week. And we should figure out what we're gonna do next week. We have a long backlog of things, but we're gonna figure it out, and we'll update y'all with what's coming next. So thanks everybody.
Thanks,
All right,
guys.
thanks for joining.
You're awesome.
Thanks, y'all.
See ya.